Ascorbic acid, more commonly known as vitamin C, is one of the most studied and biologically important molecules in chemistry. Its story connects to centuries of disease, biochemical discovery, and medicine. Ascorbic acid has the molecular formula C6H8O6 and has a molar mass of 176.12 grams per mole. Its structure contains a five-membered lactone ring, as well as two hydroxyl groups, forming what is known as a anidyl group. This anidyl group is the chemical base of the molecule's behavior. It is very reducible and readily donates electrons, which is exactly what makes ascorbic acid an effective antioxidant. The molecule is water soluble and exists in two important forms: the reduced form, L-ascorbic acid, which is the active form in the body, and the oxidized form, dehydroascorbic acid. For centuries, the absence of this molecule in people's bodies had fatal consequences on a massive scale. During the Age of Sail, spanning the 15th century to the 19th century, scurvy was the leading cause of death in sailors, having a more devastating effect than storms, combat, and all other diseases combined. Caused entirely by vitamin C deficiency, scurvy killed over 2 million sailors during this time period. Ship owners routinely estimated a 50% crew mortality rate on longer ocean voyages. Symptoms include severe fatigue, swollen joints, bleeding gums, loosening teeth, and the reopening of previously healed wounds, ultimately fatal from internal hemorrhage. Expeditions led by figures like Vasco da Gama and Ferdinand Magellan both recorded significant losses to the disease. In 1928, Hungarian biochemist Albert Szent-Györgyi isolated an acidic compound from adrenal gland tissue and Hungarian paprika, which he initially designated as hexaronic acid. By 1932, working with researcher J. L. Sverbly, he confirmed it was the long sought after antiscorbutic factor, which means that it has properties that prevent or treat scurvy. British chemist Walter Haworth determined the full molecular structure in 1933. He and Szent-Györgyi jointly proposed renaming the compound to ascorbic acid, derived from the Latin word scorbutus, with meaning scurvy, with the prefix "a" indicating its absence. Both scientists received the Nobel Prize in 1937. In the human body, ascorbic acid serves as an essential cofactor for enzymes involved in the synthesis of collagen. This explains the symptoms of scurvy, wounds that can't heal, and connective tissue that progressively breaks down. It also supports the synthesis of norepinephrine, a stress hormone and neurotransmitter in your nervous system, and carnitine, an amino acid. More recent research indicates it also plays a role in the regulation of genes. However, humans cannot synthesize ascorbic acid internally. While most mammals, such as goats, produce 10 to 15 grams per day, humans carry a non-functional version of the enzyme responsible for the molecule's final step in synthesis. This gene became inactive through accumulated mutations in human history, which is why we must now obtain it through our diet. Ascorbic acid remains a molecule with both historical and chemical significance, from its role in one of history's most devastating nutritional deficiencies to its isolation, structural determination, and integration into modern medicine and diet.